Well, good morning and welcome to class number 3. I'll go through the sequence of things in my lecture notes again. First, the schedule of assignments is always at the top of the content section of Blackboard. Second, the pages that we're going to cover today is pages 43 through 53 in chapter 2, and this is going to introduce to you the 6 major interest factors or formulas that we will use throughout the course. So it's an important lecture to understand and be able to work with. This instructor video that I'm recording right now will be available on Blackboard, and then the lecture notes that I'll be speaking from will also be available on Blackboard. So the first thing we want to talk about is single payment formulas. That is where you have just one cash flow at a time that we usually call the present, and then you have another cash flow at a future point in time. So we talk about equivalence in that at some interest rate, if you had P dollars at the present time, you could generate some future amount of dollars called F dollars. And so those two numbers are equivalent, the P and the F, whereas the F occurs at some time, we usually call it N periods into the future from the time that P occurs. So the author sort of derives the formula for the future value of a present sum. And he starts by saying, okay, if you have a present sum of P dollars and you earn interest at the rate of I, then after one period you would have interest of P times I plus the P dollars would still be there. So you would have P times 1 plus I if you factor out the P. And that's this formula, which he calls F1. F1, or I call it F1. F1 is the future value after one period of the principal that you started with plus the interest that you earned. Now, if you take this another step further, if you compound, and that's the key, in simple interest, you always earn interest on the P dollars, but in compounded interest, every time you reach a point to compound at the end of each period, you add that interest to the prior principal, and that sum becomes the new principal. So in compound interest, the sum or the value of F1 is the principal for period 2. So we'll use the same formula. It'll be F1 times 1 plus I. It will be how much you have. Well, if you have F1 times 1 plus I, then you'll earn interest at the rate I, so then you'll have F1 times 1 plus I at the end of period 2. But if we plug in what F1 is in terms of P, F1 is P times 1 plus I, so we'll get P times 1 plus I times 1 plus I, which is P times 1 plus I squared, which is what F2 is then. And you can go on and prove by mathematical induction that after n periods, the formula would be F is equal to P times 1 plus I to the n. Notice that we don't keep the n as a subscript to the F because we know what n is. It's up in the exponent of the 1 plus I factor. So this is equation 2.1 in your textbook. Now, if you solve that equation and you want to go backwards in time, you have a future value, you want a present value, then basically you divide both sides of equation 2.1 by 1 plus I to the n, and you get P is equal to F times 1 plus I to the n. The author shows you a couple of figures here. This is page 45 in your textbook. And he shows you if you're given a P, then you can find an F. And if you're given an F, you can find a P. Basically, this is called a cash flow diagram for that situation. For the situation, this would be the situation for equation 2.1, and this is the for equation 2.2. So that is the equations for the use of those factors, and I discussed that here in talking about figure 2.1. So that takes care of that. The author also discusses on the bottom of the page, and I think it's worth noting here, page 45, he shows you that the symbolic form, the notation we normally use for equation 2.1 is f slash p comma I comma n, or find f given p at rate I for n periods. That's the single payment compound amount factor. And so that's kind of our standard notation. In equation or formula format, it's f is equal to p times 1 plus I to the n. And if you use a spreadsheet function, the future value f is called fv. And then the author talks about a calculator function. We'll talk about that a little bit more. We want to talk about it more specifically with respect to Excel spreadsheets as well, not just generic spreadsheets. So we'll do that in a little bit. So the next thing I do talk about is I give an example, and the example is if you have an interest rate of 10% and your number of periods is 5 periods, then what would be the future value of $1,000 at the present time? So P is $1,000. 1 plus I, where I is 10%, or as a decimal, it's 0.1, would be 1.1, and you'd raise that to some power. In this particular example, we have, I use 8 for the power. And so when we compute that,